Okay, so let's recap what we have seen in the last lecture. We have seen the int constructor, which can convert any type of data into int. Firstly, we have seen int data. Okay, so there are other types of integers also. These are binary, octal, and hexadecimal. Their case is similar to the decimal integer. So try it yourself and let me know the results. The second case we have seen was converting float to int. When we pass a float value in int constructor, then it is converted to int with the loss of precision. Means the value after the decimal point will be lost. The third type we saw was converting the string to int. There are different cases for which the value is converted to int and the cases which gives error. The case is legal only when there is decimal integer inside string. Other than this case, binary, octal or hexadecimal numbers, any alphanumeric string, float type or string with special characters all will give an error. The fourth case was converting boolean to int. In programming, true means 1 and false means 0. So we will get 1 or 0 corresponding to the given boolean value. And at last, converting complex to int was not possible. So now let's see how we can convert different values to float. Let's start with int. We have 4 types of integer constants. Let's make a new example. We'll make a new folder inside casting coercion, that is to float. I will close all these, close all, and going to float, we'll make a new example a.py. Let x equal to float 23. This is a float constructor, okay, and we will print x. Now let's run this. cd cd to float cls a.py. This is converted to float, okay. We can also print here type of x to confirm whether it is float or not. Print type of x, type x, a.py, class float, okay. So this integer value is converted to float type. Now let's see for other types of integers also. X is equal to float 0b11 a.py. 11 in binary represents 3 in decimal, okay, and this is converted to float. Now let's see for octal and hexadecimal. 0027 and comment this a.py 23. Okay, so 27 in octal represents 23 in decimal and this is converted to float. Okay, you can see every float value is followed by 0.0, that is float, okay. Now let's quickly see the last one. Float 0x 2a, running a.py 42.0, okay, and the class is float, okay. Here you see we can convert all the types of integers to float, okay. Now let's make a new example. b.py x equal to float 2 plus 3j. Okay, converting complex to float. b dot pi. Converting complex to int was not possible. Okay, so let's see what happens with float here. Here type error is coming, can't convert complex to float. Okay, type error is coming because the type of complex is not suitable to convert it into float. Okay, that's why type error is coming. That is what type error means. Type means the data type. Okay, now let's see new example. C dot pi x equal to float 12 and print x. Now let's run c dot pi Okay, so this is the string of decimal integer, and we can convert it into float. Now let's see for float string. X equal to float 12.3. And c dot pi. Okay, we can convert a string of float number to the float data type. Okay, that was not possible in case of int. Okay, but in float we can convert string of float number to float data type. Okay, we can also see the type here, print type of x. This should come float and not string. Okay, c dot pi class float. Okay, next is x equal to float. Okay, so there is one more way to write float. I talked about this type when we saw float data type. This type was scientific notation. So do you remember how we write scientific notation? Suppose we write 12.34 E2. So let me recall. 12.34 E2 means 12.34 into 10 to the power 2. This can also be written as 1.23 into 10 to the power 3. When we shift our decimal point to left by one digit, our power raises by 1. So let's run. Okay, so we are getting the output in the float form. So remember, we can convert this type of string to float. Okay, let's check for binary, octal and hexadecimal string also. 0p11, and I'll comment this c dot pi value error, could not convert string to float. The value we have given here is wrong. See the difference. When we were converting complex to float, then it was giving us type error. This was because we can't convert complex to float. Doesn't matter what the value inside the complex is. Whereas in case of string, we were able to convert some strings to float, but for some values of string, we can't convert them into float. Here the value we have given to string are not suitable to cast into float. So this is the difference between value error and type error. See the difference, okay? Now let's check for boolean d dot pi x equal to float true, print x cls d dot pi. Okay, for true we are getting 1.0, and for false we will get 0.0. Okay, let's see. Okay, 0.0. Okay, that was simple. Now e dot pi. Now one type is left, that is converting float to float. Okay, there is nothing to see in it because float is already in float data type, so why one will convert float to float? But still, let's see. 12.23, it is already in float, so we'll get the same value. E dot pi 12.23. Okay, and we can see for scientific notation also 23, let's say. E dot pi 1.223 e plus 24. Okay, here the case is same. 12 is converted to 1.2. When the decimal will shift towards left, the power will raise by 1. Okay, and if the decimal is shifted towards right, the power will decrease by 1. Okay, that's it. You can do more practice if you want. And that was all for today. In the next lecture, we'll see the Boolean constructor. Thank you.